Hi everyone, so today I will be showing you guys how to do this FRQ from the 2010 AP Calculus AB test, and this is number 2. And let's start by reading the question, and it says, a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon t=0 and 8 p.m. t=8. The number of entries in the box t hours after noon is modeled by a differential equation. E for 0 is less than or equal to t, which is less than or equal to 8. Values of e to the t in hundreds of entries at various times t are shown in the table above. So now we can start with part A, which says use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t=6. Show the computations that lead to your answer. And we will be using this part of the chart for this question. And we need to use the rate of change formula because that's how we approximate the rate. So we have to do E at 7 minus E at 5 over 7 minus 5. And by looking at this chart, we can fill these in. So you get 21 minus 13 over 2. And the 2 you get from 7 minus 5, which equals 4. And in our case, it's actually 400 entries per hour. So don't forget to add the units. So 400 entries per hour. And the units are very important, so never forget to add these. Now we can start with part B, which says use a trapezoidal sum with the 4 subintervals given by the table to approximate the value of this function. Using correct units, explain the meaning of this function in terms of the number of entries. And now we can get started on this part. So the first thing you do is you should write down the function that it gives you again on your paper, just so you can have it to look at while you're solving for it. And we know that we need to use trapezoids in order to find this integral. So you do 1/8 times 2 times 4 plus 0 divided by 2. And you do this because 2 is the width that it is, and you have to do 4 plus 0 because those are the technical heights of the trapezoid. And you have to just keep adding the rest of the trapezoids. So you get 3 times 13 plus 4 over 2 plus 2 times 21 plus 13 over 2 plus 1 times 23 plus 21 over 2. And this gives you 1/8 times 4 plus 25.5 plus 34 plus 22. And then when you divide all this by 8, you get 10.687. And this continues, but since this is calculus, we have to either truncate it at 3 decimals or continue on and round it at this point. And you always need at least 3 decimals. The other part of part B asks us what this function means, and this function is basically the average number of hundreds of entries an hour in the box between noon and 8 p.m. And this is because when you think about finding an average, you basically add everything that you have up and then you divide it by the number of portions that you had. And this is the same thing because by doing the integral, this is a total number of entries, and then to find the average in an hour, you have to divide by 8 because this is in 8 hours. And then to get it by 1 hour for the average, this is what you get. Now we can move on to part C, which says, at 8 p.m. volunteers began to process the entries. They processed the entries at a rate modeled by the function p, where p of t equals t cubed minus 30t squared plus 298t minus 976 hundredths of entries per hour for 8, which is less than or equal to t, which is less than or equal to 12. According to the model, how many entries had not yet been processed by midnight, t equals 12. So how to solve part C is you need to find how many are not processed by midnight. So what you have to do is you have to do the total number of entries subtracted by the number of entries that are already processed by 12 o'clock. So we do this by doing 23 minus the integral of this. And the integral of this is how many are processed by 12. So you do integral of p of t, which is 23 minus from 8 to 12, the integral of t cubed minus 30t squared plus 298t minus 976. And you get 23 minus 16, which equals 700 entries. I will show you guys how to do this calculator work with your TI-84 Plus. Finally, we can do part D, which says, according to the model from part C, at what time were the entries being processed most quickly? Justify your answer. To do part D, we have to first write down the function again. We will see that we need to find the absolute max because we have to find when it is processed most quickly, which is the most maximum, which is the absolute max. And to find the absolute max, we need to find the first derivative of p of t. So the derivative of this is just 3t squared minus 60t plus 298. And then if you plug this into the calculator, the graphing calculator, we can find the zeros of p, the integral of p of t. So the zeros are at t equals 9.183503 and also at t equals 10.816497. So now I'll show you guys how to find the zeros of the derivative of p of t. And it guesses the 0, and this is what we have down here. And then you just have to do the same thing for the other 0 right here. So doing that was finding our critical points, and in order to find the absolute maximum, you have to plug in the endpoints and the critical points. So we need to do a table and just plug everything in. So once you plugged everything in, we need to find the absolute maximum, which is the greatest value. So it's clearly 8, which is at 12 so the answer is t equals 12. Now I'm just going to go over some common mistakes, and the first one is forgetting to write units, because even though some questions might not have to include units and you might not have to write them in the answer, it's always best to just include it just in case, because even if you write it, you won't get points taken off, so it's just a safety net. And another one is forgetting to do the dividing by 8 at the end of part B, because if you recall, you have to multiply part B by 1/8 to find the average. And some people might forget this since it's at the very beginning. You might just do the other main part of the problem, but that won't actually give you the correct answer. And this one is not subtracting the integral of p of t from 23, because some people will forget the 23 part and just do this integral. And the last one is not testing the endpoints when finding absolute maximum, because some people may forget it is an absolute maximum, so you must test all the points, including critical points and endpoints.